Okay, how's everybody today? I'm doing well. It's Friday. We got a 3-day weekend, so things are looking up. Okay. Just a couple things. In fact, Andrew was talking to me before he came in. Let me go ahead and get that paper to him. There you go. Andrew, just whenever you can get that to me, sir. All right. Okay, so we have been talking lately about trig identities, and we haven't gotten to all of them yet. We may or may not get to the rest of them today. I would say definitely by Tuesday. But the only other thing we really need to be looking at down the road is Thursday of next week, the 24th, where we're going to have our first exam. Okay, so it's 11 questions, 10 multiple choice, so hopefully it's not going to be too bad. Please take a little bit of time, look over your notes. You are able to use your notes on the test. Okay. It's going to cover these identities that we've been discussing so far and inverses. Okay, very similar to what you did yesterday on your exit ticket, what we did last week. Okay, so here are the ones we've been looking at up till now. We've got the 6 reciprocal identities, sine and cosecant are reciprocals, secant and cosine, and then cotangent and tangent. We've got our quotient identities, tangent equals sine over cosine, cotangent equals cosine over sine, and our 3 Pythagorean, with sine squared plus cosine squared equal to 1 being the big one. That's definitely one that can actually be used to get the others. Then we have 1 plus tangent squared equals secant squared. And we have 1 plus cotangent squared equals cosecant squared. And we've done a variety of problems, but I thought before we move on with the notes, it'd be a good idea. Let's go ahead and practice a few more of these expressions. Okay, so this is not in the current packet that you have. If you want to jot these down or if you just want to follow along, okay, whatever you like. Now, all of these will simplify to a single expression. Okay, so there's one I'm going to say for the last because it has a few more steps. So why don't we go ahead and start with this one? Let's say secant squared of theta minus 1 over secant squared of theta. Okay. All right. Now, is there anything that you immediately notice? Any identities you recognize? Now, we can't cancel. If it was just one over the other, if we were multiplying, yes, then we could cancel. But with the binomial, we have to look at the entire group and not just the individual terms. Okay. It's kind of the same idea. You know, if I had A plus B divided by A, I can't cancel the A's out because A belongs to something bigger. Okay. We do have a Pythagorean, yes. Now, what Pythagorean involves secant squared? Okay. So 1 plus tangent squared is equal to secant squared, right? So I want to rewrite this so that it looks like secant squared minus 1. Okay, so I'm just going to change the formula, you know, like we're solving an equation. So minus 1, minus 1. Okay, those opposites are going to cancel. So there is secant squared of theta minus 1. What does it equal? Tangent squared. Okay, see, what a lot of people do, a really good strategy, is to rewrite everything in terms of sine and or cosine, right? But I would say look to see if you recognize any identities first. Once that's done, then go ahead and take a look at sine and cosine if necessary. All right? So we just showed that secant squared minus 1 is tangent squared. So I'm just going to replace that with tangent squared. Okay, and I've still got the secant squared of theta right below it. See, now I'm not recognizing anything else. I would go ahead and go to changing things to sine and cosine. Now, we also know tangent of theta is sine over cosine, right? So what would tangent squared be? There you go. We still just go ahead and apply the square to each of those trig functions. So up top, I've got sine squared of theta over cosine squared of theta. Now, what can I do with secant squared? Okay, so we know that secant of theta is just cosine or what? 1 over cosine, right? Okay, there we go. So secant is 1 over cosine because they are reciprocals. So secant squared is 1 over cosine squared. Does everybody follow along how I'm doing it? Okay. Now remember, is this the only way this problem could possibly be solved? No, it really depends on what identity you recognize, what algebra techniques you use, okay, because there's a lot of ways. So now, what's the algebra rule here? If I'm dividing by a fraction, you multiply by the reciprocal. Okay, so I'm going to go ahead and move this to give myself a little bit of room. So I'm going to multiply by the reciprocal. Sine squared of theta over cosine squared of theta times, flip this fraction, cosine squared of theta over 1. And then why does that help me out? There you go. So those cancel, and the only thing I have left is sine squared. And remember, I said it was going to simplify to a single trig function. Okay. Now, that won't always happen, but I'm going to try my best to go ahead and start you off with all these expressions that do simplify down to a single one, and then we can look at some other ones later. Okay. All right. Questions? Let's try another one. Okay, so next example. Let's see, which one do I want to do here? So I just did that one. Okay. How about, let's do this one. Okay. Secant squared of x, secant squared of x, minus tangent squared of x, plus cotangent squared, and that's it. This one will simplify down to a single trig function. Okay. Now, I'll even go ahead and tell you on this one, you could simplify this without changing anything to sine and cosine. You could do that, but what you're going to have to do, since you'd be creating a fraction and you're adding it to other terms, you'd want to get a common denominator. Now, that is absolutely a way we could go. There you go. Now, all those are squared, but there's one Pythagorean identity that I'm thinking of. There we go. That's the one I was thinking of. 1 plus tangent squared is equal to secant squared, right? Because you'll notice that Pythagorean identity contains both those terms. So could I rewrite this identity to look like secant squared minus tangent squared? Yeah, okay. So I just need to subtract the tangent squared over. Okay. So tangent squared minus tangent squared, those are gone. So there's the secant squared of x minus tangent squared of x, but it should equal what? 1. See, all I did was change the equation. Okay. So I know now that secant squared minus tangent squared is 1. So I'm just going to replace this with 1. And then we have plus cotangent squared of x. There you go. Because you recognize this is part of a third identity, Pythagorean, we know that 1 plus cotangent squared equals cosecant squared, and that's exactly what we have there. We don't even have to manipulate the guy this time. We know it has to be cosecant squared. Okay, how are we doing? Okay. Now, it might take a little more work. Would anybody like me to change everything to sine and cosine and get a common denominator? Okay. You know what? Second thought, let's wait on that. Because I think everybody's doing pretty good right now, right? Okay. So I don't want to, do anything that's going to confuse somebody. I just want you to realize that these are not the only ways these can be solved. Okay. Yes. If we have time at the end, we should have time. Okay. All right. Let's try another one now. So we did that one. How about... Actually, you know what? Yeah, let's do one where you have to work with a fraction. Okay. So let's try this one. Cosine of x times secant of x minus cosine of x over secant of x. Okay. Now again, this will simplify to a single trig function. Okay. So this one, I think it's easy enough. I'm going to go ahead and show you a lot of different ways you could do it. Okay. All right. So any ideas? How do you mean separate it?
Like, you know how usually sometimes, like, if it's just a fraction, we can take off cosine x, so it would be 1 over secant. Well, secant goes...
Oh, so you're wanting to change cosine to 1 over secant?
Yeah.
Or you want to change secant to 1 over cosine? We could do that. Now, if I go ahead and do that, okay, secant by a reciprocal identity is 1 over cosine, and if I multiply that by cosine, those are going to cancel. But what am I left with? 1. So this expression here is actually 1. And really that makes sense because we know cosine and secant are reciprocals of each other, right? Minus. Well, would you like me to do the same thing here?
If we change cosine x to like 1 secant, wouldn't that just be secant over secant give you 1?
Well, what I would do is try to change it so that you have the same trig function. So why don't we keep the cosine as is, and we know that secant is 1 over cosine, right? That's what we just used a second ago to help me out. So again, we're dividing by a fraction. So what does that mean? Okay, we're going to multiply by the reciprocal. So I've still got this one here, minus. So the cosine on top, I'm going to go ahead and put him over 1 because we're about to multiply it by another fraction. So this one here, I'm going to multiply by cosine over 1 because that's a reciprocal of 1 over cosine, right? Well, now multiply those together. What is cosine times cosine? See, that's cosine squared. And now we have 1 minus cosine squared of x. What Pythagorean? There you go. We know that sine squared of x plus cosine squared of x is equal to 1, but I want this equation to equal 1 minus cosine squared. So if I subtract that over, and if it helps to do like I've been doing, if you know what property or identity it is you're going to use, if you need to write it over to the side and manipulate it to help yourself out, that's perfectly fine. But you might do enough of these where you start to know what you're going to get. Okay, 1 minus cosine squared of x should equal what? Sine squared. Okay, and see, that's exactly what we have there. So my answer is just sine squared of x. How we doing? Okay. All right. Let's see. Now, would there be another way to solve this one? Yeah, let's solve it again. Now, let's choose a different way.
Start with the fraction. Like, we can take the, you know how like we did it the last time? So it was like 1 minus cosine x squared.
Uh-huh.
We could, or never mind, my bad. It could just be like cosine x, like secant x minus cosine x squared. You know what I mean? Like instead of like it showing us the whole problem again.
Uh-huh.
Never mind.
Huh?
Okay, no, I'm good.
Okay.
Yeah.
Well, another way we could go ahead and create a common denominator. We could pretend that cosine secant is over 1. Okay, so we could get a common denominator. We could go ahead and do the exact reverse of what we just did a moment ago. Okay, we took the reciprocal of the secants. Could I take the reciprocal of the cosines and solve what I get? Okay, which of those sounds like the better option? Take the reciprocal of the cosines or create a common denominator? Create the common denominator? Okay. So let's see here. I'm going to go ahead and say this is over 1. Cosine of x times secant of x over 1 minus cosine of x over secant of x. Now, a really good rule of thumb when you're doing these kind of expressions, you're trying to figure out what a common denominator is going to be, I would just take the denominators that you have and multiply those together. Okay. So here, what's 1 times secant? Secant. So I want my common denominator to be secant. Okay. It's like if I were going to go ahead, I mean, this is not going to always be the least common denominator, but it's always going to be a common one. And it'll be the fastest way to go ahead and pull these together. Okay. So here's the thing. I need both of these to be secant on the bottom. Well, this one already has secant, so what am I going to do to him? Nothing. I'm going to leave him the way he is. But this one here, okay, I've got to multiply the bottom by secant. Because what's secant times 1? Well, that's going to be secant, right? But here's the thing. Remember, in mathematics, you have to be fair. I got to multiply the top by the exact same thing. Okay? Because think about it. What is secant divided by secant? It's 1, right? What happens when you multiply 1 times anything? It stays the same. So see, whatever value cosine times secant has, well, we know it's 1. I don't want to change that. I just want to change the way he looks so that I can perform this operation. Okay. So let's see. What would I get if I multiplied secant times cosine secant? There you go. So wouldn't that be cosine secant squared? Because secant times secant, right? Okay. Now secant times 1 gives me the secant. Minus, now this fraction we didn't touch. Okay. So is everybody okay how I now have a common denominator? Okay. Well, once you have a common denominator, we can combine the fractions. So I'm going to put everything over secant of x. I'm just going to combine the numerators. So this is going to be cosine of x secant squared minus cosine of x. Okay. Now what? The cosines cancel? It's not that they cancel. Okay. Can't cancel the secants because, see, that belongs to a group. There is something I can do in the numerator, though. Think about one of the strategies we have, factoring. Hey, what do both numerators have? They both have cosine, right? Okay. There you go, sir. So imagine, remember the other day we were doing this with the variables? Imagine this was a times b minus a. Well, I can pull out the a. That'd be a times b minus what? Remember how the other day we were doing this with variables? Okay. So if I were to pull out that a, that would leave me b minus 1. We're just doing this with cosine and secant. Okay. So I'm going to pull out that cosine, and that should leave me secant squared minus 1 over secant of x. So is everybody okay with what I did? I just factored the cosine out. Okay. Because cosine times secant squared, well, there's your cosine secant squared. Cosine times 1, there's your cosine. Now, by doing that, does anything look familiar? The secant squared minus 1, that becomes tangent squared. Why is that? Remember, we have the Pythagorean identity. Does anybody want me to write the identity out again, or at this point, do you feel comfortable with that? Okay. What do you guys? What would you like me to do? Would you like me to write out the identity, or just replace it? Write it out. Okay. So we know that 1 plus tangent squared of x is equal to secant squared of x. So I'm going to go ahead and subtract the 1. Okay. Those cancel. So secant squared minus 1, forgot the x, is equal to tangent squared of x, right? So I'm going to replace this binomial with tangent squared. So cosine of x times tangent squared of x all over secant of x. Okay. Now what? Remember, we know the answer is what? It was a squared term. What was it? Okay. So we know we should be getting sine squared. So what other identities or rules do we have that I could use? Tangent is sine over cosine, right? Okay. So we could say cosine of x times, this would be sine squared of x over cosine squared of x all over secant of x. Okay.
And if the cosine,
Okay. We're almost there. There you go. Secant is 1 over cosine, right? So we've got, let me give myself a little more room. We've got sine squared of x over cosine of x. Now instead of secant, we're going to say 1 over cosine of x. And we multiply by the reciprocal. So sine squared of x over cosine of x times cosine of x over 1. And what happens? And see, this is what you're going to come to see the more experience you get. How long did it take us the first time we went through that problem? It was like a step or two, right? It was really fast. Now, is everything that we did here right? Yeah, we followed every one of those rules, but it took me a little bit longer to get to the same answer. And you're going to start to see that. You'll start to think, okay, if I go ahead and use this identity, then it's going to force me to do this, and it's going to take a lot longer. Is there a shorter way? And a lot of times there probably is. Okay. How we doing? The one thing to remember about these problems, don't get frustrated. Okay. If it starts to get way too long or starts to get too complicated, just go back and try to find another way. Okay. There's always another way to solve things. Okay. Cool. All right. Well, now let's go ahead and get back to the notes. Let's see here. We did our factoring. We did this one yesterday. Does anybody remember those groups? The A plus B, A minus B. What do we call those? Started with a C. Conjugates. When we multiply conjugates, we get difference of squares. Okay. All right. Now simplify by combining fractions and using identities. Okay. So cosine of x over 1 minus sine of x over cosine of x. We could, I think that might make it more complicated. Yeah, I think so. If you're given two fractions like this, probably a really good idea is to try and simplify it into one fraction. So this one here, we do need a common denominator. Okay. So what was the hint I gave you a moment ago if you're looking for a common denominator here? Just multiply them together. Now, what I would, again, go ahead and advise, sometimes it's better to actually multiply them together, like, say, distribute, and sometimes it's better to just multiply them and keep them separated. Again, that's something you're going to come to notice the more of these you get to work. But here's the denominator for the first one. Here's the denominator for the second one. So what I need both of them to look like is cosine of x times 1 minus sine of x. I need both denominators to look like that. Okay. Now I'm going to go ahead and tell you on this one, it's probably better in the long run if I don't distribute. If I don't multiply cosine times 1 and then cosine times sine. Okay. There you go. Now you'll see why in just a moment. So let me set this up. Here's cosine of x over 1 minus sine of x. And I want to subtract sine of x over cosine of x. Okay. Well, here's the denominator that I need, but I only have 1 minus sine of x. So what is he missing? All I got to do is multiply by cosine. Is everybody okay? All right. Now the same thing on the other side. I've got the cosine, but I'm missing what? The 1 minus sine. So 1 minus sine of x. 1 minus sine of x. Okay. Now, let's go ahead and multiply these together. All right. Now, if you start to feel comfortable where you can multiply and combine at the same time, please feel free to do it. But if you have to take one step, that's fine. Okay. So let's multiply these across. What's cosine times cosine? So that's cosine squared of x over cosine times 1 minus sine of x. So all I did was multiply those two together. Is everybody okay? All right. Well, now I'm going to do the same thing over here. Okay. Now I'm going to go ahead and distribute. Now, you may or may not need to multiply the denominators together, but I always recommend multiply the numerators together. You'll want to do that. So what is sine times 1? Sine. Hello. Going in. Okay. So I'm going to set up this other fraction over here. So sine times 1 is sine of x. Now what's sine times a negative sine? There you go. Negative sine squared x. And what's this going to be over? Okay. Cosine of x, 1 minus sine x. Okay. So first off, is everybody okay, with how I got a common denominator? How I figured out it was cosine times 1 minus sine. Okay. Is everybody all right with how I multiplied each fraction by what I needed and I distributed? Okay. Now, actually, we don't have much further to go. Okay. It's only going to be a few more steps. What can I do now that both fractions have the same denominator? I'm going to combine it all into one fraction. Okay. So the same denominator, that's just cosine of x times 1 minus sine of x. Now these numerators are going to go up top. So I'm starting with this first one, cosine squared of x. But what do I have to be very, very careful of when I pull these together? The minus. Now if it's a plus, you're not going to have to worry about this. But if you're subtracting two fractions and you're going to combine them, you have to distribute that negative. Okay. So this is going to be minus sine x, what? Plus. Why is it plus? Because you're subtracting a negative, right? Okay. And we are right there. Does anybody see it? What Pythagorean? Okay. So does anybody think they know where we're going? What our answer's got to be? Oh, we're close. Our answer is just going to be a single trig function, but it's not going to be a fraction. Yes! Okay. So some people have already seen where we're going. Is everybody okay? Let me do this. Let's say you don't see what it is they're talking about. Let me rearrange the terms. Cosine squared of x plus sine squared of x minus sine of x over the cosine x 1 minus sine of x. Now remember, I just rearranged the terms. Okay, there's nothing wrong with doing that. But the reason I did so is because it's easier for people to see that. This is what Lexi and Brandon were talking about. What is cosine squared plus sine squared? That's 1. So if I replace that with 1, I've still got the 1 minus sine of x over cosine of 1 minus sine of x. And what do you notice? Now those can cancel because it's the exact same group, right? Those cancel. I've got 1 over cosine, and what is that? That's secant. Bam. And see, that's why these are so fun to me. It's like a little puzzle. Okay. What can I do with the rules that I know, those Pythagorean identities, the reciprocals, the quotients, in order to manipulate this expression down to a single term? Okay. How are we doing? You didn't write any of that? Okay. Do you want to copy it? Or do you want to take a picture of it? Looks like I won't be able to get the entire thing on there, but I mean, you know the original problem. So yeah, I guess you can't say the whole thing is up there. Okay. Yeah, are you going to write the whole thing out, or are you going to take a picture of it? Photo memory?
Works that way, Brandon.
Okay. So I'll tell you what, you guys have done a great job today, and we've gone over some problems that have been a little longer. Okay, and you've hung in there with me. I'll tell you what, let's do this. I'm going to go ahead and give you another one. Okay, but I'd like you to take a look at this one over the weekend. It's just one problem. We'll come back on Tuesday, and we'll go ahead and turn it in. Okay? And this one isn't even a huge one. Okay? So one problem for homework. That's it. Is everybody okay? All right. So here's the one problem. Okay. Okay. It is tangent of theta times cotangent of theta minus cosine squared of theta. Okay. So I will tell you this will simplify down to a single trig function. No fraction, just a trig function. Now, it may be multiplied by something. It may have some kind of power, but it's just going to be a single term. Did it come out good? Oh, she didn't say anything. What's up? Just write on a sheet of paper. We're going to simplify it. Okay. Get a little bit of practice. For homework, yes. Okay. And then we'll go ahead and continue to finish the rest of the notes on Tuesday, and we'll see how far we get. Hey, now you can go to the bathroom. Yes, sir. Okay. Don't you guys think these problems are fun? No? Oh. Okay. But you feel really good when you get down to the end. You're like, I did that. Right, Andrea? Sure. I do have a lot of tissues. There you go. It's fun.
No, I mean,
Does it relax me?
Yeah.
Depends on the math I'm doing. Because even I do math that makes my eyes glaze over from time to time. No, actually, I kind of just probably listen to music or watch some videos that would make me laugh.
Can we watch videos? Okay, let's